Okay, buddy. So I wanted to show you another example about graphing something in polar coordinates. Okay. So for this one, I do think it probably is a little bit more complicated than some of the ones I've showed you so far, but I'll let you decide once you see what I have to say about it. But suppose that we want to graph r is equal to 1 over 1 plus cosine theta. So some initial observations about this. This could be undefined, okay? So when I go to sketch the graph, whatever that may look like, I want to keep in mind that at negative pi, or any angles coterminal with those angles, this will be undefined. The reason is because over there at 180 degrees or negative 180 degrees, cosine is negative 1, and 1 plus negative 1 is 0, and then we'd be dividing by 0. Okay, so that's my first observation. Now, what I will end up showing you is that I want to make a table, okay? That's at least one way that we can draw any graph, is we can make a table, and on the table are going to be points, and the points are going to suggest what the graph looks like. But if this is in polar coordinates, I could convert it to rectangular coordinates to see if that gives me more insight into what the graph is supposed to look like. So, in other words, suppose I converted this to rectangular coordinates and then it became the equation of a circle. Well, then I would know it was a circle. So I'm going to at least try that, and I think it is something that you should see. So this will give me the chance to show you. So suppose we want to take this, r is 1 over 1 plus cosine theta, and convert it to rectangular coordinates. Well, what that would mean is that I need to get my conversion equations to show up somehow. Meaning, isn't r cosine theta convertible to x? If you have r cosine theta in polar coordinates, that's equals to x in rectangular coordinates. So here's what I did. I take this, I'll multiply both sides by 1 plus cosine theta. Okay? Then I'll distribute the r, and I'll get like that. And then I realize r cosine theta, at least that is equal to x. So I guess I'm part of the way there. You see the x. Now I'll move the x over to the right-hand side. And I see that I would have this isolated r. What am I going to do about that? If I'm going to convert this to rectangular coordinates, the r and the theta have to be gone. And I introduced only x and y. So what about r? What do we do with that? Well, so remember that r squared converts directly to x squared plus y squared. So then I had the idea that, well, I'll square both sides of this equation, because then this conversion can be introduced. So I square both sides of the equation like so. And then r squared, like I was saying, is in fact x squared plus y squared. So I get this. X squared here cancels with x squared here. Okay? And now I get this. All right. Now, once I got here, this looked familiar to me. And I thought, that's a parabola. I don't have the best memory, but I know that that is some kind of parabola that opens either left or right. Okay? In fact, the equation for such a parabola is y minus k squared equals 4p times x minus h. If you have that equation, it is a parabola that has a vertex at h and k, and it'll open left or right depending on the sign of that number right there. Okay? So with just a little bit of work, I can get an equation that's like that. Okay, you see this right here? I can introduce that this way. Okay, if you distribute that 2 again, then you'll get back here, but that's that overall form that we see there. Okay, even though I don't explicitly see a 4, okay, that's a number, okay, and it's negative. So what this is yes, that it is in fact a parabola, and it opens to the left, and it has a vertex at 1/2 for x and 0 for y. So here's the graph in rectangular coordinates. And I guess at that point, then I've done it. I know what it looks like. Okay, so that's one approach that you can have. Now, I would like to use this though, not as something I show you by itself, but as a supplement to looking at the polar coordinates of this one in a little bit more detail. So what I decided to do is I thought, well, if it's undefined at negative pi and pi, maybe I should like start here and work my way up. You know, I'll make a table where I start theta at negative 3.14, which was about negative pi, and I'll work my way up a little bit at a time. So I decided to make a table, negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0. And I'm just like counting my way upwards from negative pi to pi by increments of pi over 4. That's what you see in my table. And I did the calculations for r being 1 over 1 plus cosine theta. And it's, of course, undefined at negative pi and pi for reasons I mentioned earlier. And otherwise, they're getting these numbers, negative 3.4, 1.6, 0.5, 0.6, 1, 3.4. Now, over here, I did take my time to draw that picture, all right? And in fact, when I say rotate negative 3 pi over 4, and I radially go in that direction, 3.4 units of distance, I actually got my protractor and I decided my distance units would be centimeters. So I actually measured out 3 pi over 4 clockwise and then went radially in that direction, 3.4 centimeters. And same with all the other points. There is negative pi over 2 and 1, and then negative pi over 4 and 0.6, and then 0 and 0.5, and so on. Okay? All right, so I did try to make it accurate. Now, I feel like I have confirmation then of what we were talking about already. Okay? Because we said, well, it's going to be a parabola. All right. And there was just the abstract shape that we would take. It would open to the left and have this vertex there on the positive x-axis. And sure enough, look at that point. The angle is 0. The radial distance is 0.5, right where the vertex should be. Now, I thought I would do a little bit more than this. So suppose that, kind of imagine this graph is really a parabola, like so, okay? What if my angle was 5 pi over 6? The radial distance would have to be pretty far, right? Because this parabola kind of sweeps over like this, okay? And so I thought, well, just, how about this? Let's add negative 5 pi over 6. So that'd be negative 150 degrees. Again, the radial coordinate have to be pretty far out there to get where this parabola is going by the time it's at negative 5 pi over 6. And then I thought, why not do 5 pi over 6, just to get some additional points and some confirmation of numbers. So if I do this or this, r turns out to be 7.5, okay? And that turns out to be too big for my piece of paper. You know, if I was going to, in that direction, go out 7.5, well, maybe not, maybe not. So there's 7.5 centimeters. So right here, whoops, it'd be right over here. It'd be on my table. And then for this one, also 7.5. So it'd be like about right there. And that seems in line with this parabolic shape that I see on those points. Okay, so I'll go ahead and sketch it at this point. So it's going to go like this and over and so on. And do you have to draw it this neat? Maybe you don't even think my picture is very neat. I don't know. I'm just trying to give a good demonstration for you. Maybe I am taking it too seriously. But it doesn't hurt. There you go. Okay. Now, another thing I think about this is, well, all right. So at negative 150 degrees, you get 7.5. And at a positive 150 degrees, you get 7.5. What do you think happens as you tilt closer to 180? Those points are going to get further and further out, aren't they? And what happens as you tilt closer to negative 180? Oh, those points are going to have to get further and further out, aren't they? I mean, look at where the curve's going. So, you know, I would imagine like at 179 degrees, that r coordinate is going to be really big. So you'll find like one additional detail on the table is that if theta is going to pi, all right, from below, then r will go to infinity. Okay? As you lean this direction, as your angle leans closer to pi 180 degrees, r is going to have to be further and further out there to land on that curve. And as theta goes to negative pi, all right, from above, then r will also go to infinity. So from that, then I can get a little more insight about it, that over that interval, the entire curve, every single point on it, the whole thing will be traced exactly once. Okay? You'll get this part as you go from negative pi to 0. You'll get the vertex when theta is 0. And you'll get this entire part as theta goes to pi. Or as from 0 to pi. Sorry about that. All right. And that's basically what the breakdown of my table is. Okay. So that's... I meant to not only do this question, but make it a little bit comprehensive so that we could look back on this and see lots of different things. You've got polar coordinates. You could convert it to rectangular coordinates and see some insight about the graph that way. Of course, you'd have to be familiar with this equation in rectangular coordinates that is a parabola, but that's something that I think all of us have seen before if we're in Calculus 2. There are the points. There's the overall trend on the table. The points confirm the shape that we have. And we can see that we get all the points by working our way from here over to there. And we get the whole thing.